Welcome to aminacademy.com. In vector calculus regarding Fernet-Serret formula, let us do some solving problem. Example, find the radius of curvature of the curve with parametric equation x equal to x of s, y equal to y of s, z equal to z of s. Here, the position vector of any point of any point on the curve are equal x of s I plus y of s j z of s k is the position vector of the curve is given by r equal to x of s I, y of s j plus z of s k. Now, then you can say vector t equal dr by ds. That is, r is already given the position vector. Then you can write dx by ds I vector plus dy by ds j vector plus dz over ds k vector, and differentiate this one dt over ds. dt vector over ds is d square x over ds square I vector plus d square y over ds square j vector plus d square z over ds square k vector. Now we can write that dt vector over ds equal curvature k into n vector, which shows k kappa is delta t over delta t vector over ds modulus, which is equal to square root of, that is kappa is square root of d square x over ds square whole square plus d square over ds square square plus d square z over ds square whole square. Now this is k. Now radius of curvature, therefore radius of curvature rho equal 1 over kappa, which is equal d square x over ds square whole square plus d square y over ds square whole square plus d square y over ds square whole square. This is power minus half, because the reciprocal of curvature is radius of curvature. Now let us do one more problem. Here show that the acceleration a vector of a particle which travels along a space curve with velocity v vector is given by a vector, acceleration vector equal dv vector over dt into t vector plus v square over rho into n vector. We'll do this problem. Here we have to prove this. First, v vector, where here t vector is unit tangent vector to the space curve, like n vector is unit principal normal, vector, and we know that rho is radius of curvature. We have to find the relation among these things. Now we know that v vector, velocity vector, is v into t vector. Differentiating, we have differentiate v vector is a vector, that is equal dv over dt, which is equal d by dt of vt vector. Now this is a product rule which gives dv by dt t vector plus v into dt over dt. Now we know that dt by dt vector over dt is dt vector over ds into ds by dt. That means here ds and ds cut, which will give dt vector over dt. We will write regarding this expression, you can write k n vector ds by dt. That means dt by ds is k into n vector. Now which is k n vector, I can write k ds by dt is v into n vector, which is further equal v n vector over rho. K is 1 over rho, we write here. Now dt by dt, we got that, therefore acceleration vector equal dv by dt into t vector plus v into v n vector over rho, which is further equal dv by dt t vector plus v squared by rho, here v into v square by rho n vector. This shows that the component of the acceleration is dv by dt in a direction tangent to the path and v squared over rho in the direction of the principal normal to the path. So hence we prove we have done. Please subscribe our YouTube channel.